one component in the sealed system, the heat pump system, your electronic expansion valve, EEV. Right, we can. It's a necessary. It's an integral part to the system. It's the metering device. So what the control is doing is we're monitoring temperatures into our evaporator coil, out of our evaporator coil, a few different points, and that's the wire harness here. 3A and 3B sensors. So we're going to have to do some testing. How do we know when the EEV is bad? Positioning of the sensors, pretty critical. Remember, if it gets too low on your line, you're probably looking at liquid temperatures, not necessarily the gas. So positioning of your sensors is critical. Knowing how to measure the resistance, what that resistance correlates to as well as temperature. So resistance checks there, and remembering we're going to have the meter set 2 ohms, right? But on the EEV, you've got two different pieces here. You've got the actual device here that the control sends 12 volts DC. It's a DC voltage. It's actually moving the components inside here to increase or decrease refrigerant or freon flow. So we can't necessarily measure that voltage with our meter, but what we can do is measure resistance of the coil that connects to the actual EEV. So in doing that, remember that the gray wire is actually your common wire, and the resistance value we're looking at for each one of these tests is 46 ohms. You have an allowance there, a little bit of wiggle room of about 3 ohms. But if I go to any one of these other connection points, we should see a resistance value somewhere close to 46 ohms, right? So we have that sealed system problem. We've done the visual checks. We're not necessarily seeing the evidence of leaks, but you become suspect of EEV. Remember, we can check coil resistance. We can check sensor resistance, put some things in perspective for you. But at some point in time, before we condemn the system, meaning you have to break into it, you actually have to break into it. Using practices, best practice piercing valves, we got to put the gauges onto the high side, the low side, see where you're at with a refrigerant charge. Remember, it's 134A, and if we got to add, you're going to have 30 ounces as your total charge there. But resistance checks, but ultimately, as a refrigeration technician, throw the gauges on, give us a call if you got any questions.